Hello everyone. So in this video we will try to solve a classification problem with the help of graph neural networks, and it's the same dataset, Lipophilicity dataset, that we will be using. So we will talk about that in a minute. Before that, let's just go ahead and install RDKit and Torch Geometric like before, so that we can generate our graph data. And of course, with the help of Pytorch Geometric, we are gonna be defining our models and training and evaluating them. So after it has been successfully installed, we will import several other traditional libraries and import certain modules from RDKit and Torch Geometric. So it has been installed, and let's run the next code as well. Let's set the matplotlib style to ggplot and random seed to 50. Call the function. So this is the Lipophilicity underscore final dataset that we had and we have been using for our regression problem, and we are going to be using the same dataset in this problem. So let's just have a quick look at this dataset. So this one has Campbell IDs, experimental lipophilicity values or log D values, and smile strings. And if you wanna see the more information about it, then we can just call a describe method, and you can see we have 4192 data points, and mean is for the experimental values is 2.18, and all these other metrics. So it's just the same code which we have run here. So yeah, so now since these are numbers, these are numerical values, and for classification problem we need to convert them into labels. And what I'm gonna do is, as you can see here, the median is 2.36, so I'm gonna convert it into labels of 0 and 1, 0 being less lipophilic and 1 being more lipophilic. And we can use here list comprehension and with the help of map function. So what I'm doing here is, if the log D value or experimental value is more than 2.36, it will be 1 or more lipophilic, and if the value is less than 2.36, it would be 0. So all these values will be stored in the form of a list, and we'll just count the zeros and ones with the help of counters. So we have ones 2088 times and zeros 2104 times. So the data set is quite balanced. And what we are gonna do next is, I'm gonna create another column in the data set with the name labels, and it would have all these values. So let's have a look at the data set. So as you can see here, we have now the labels. This is more than 2.36, so it has a value of 1. This is less than 2.36 and it has value of 0, and so on. So now we don't really need this column, and all we are gonna do is utilize smile strings and labels. So now we are gonna be generating graph list. We are gonna loop through each and every smile strings, and of course we are gonna be adding the labels as well. And it is just the same code, similar code which we have run before for generating graphical data in our regression problem. So if you wanna see the length, so we have 4192 graphs, and let's split it into train and test set. And again we are gonna be splitting into 80 to 20, 80% for training and 20% for testing. So it is just the same procedure which we have used before, and the generator here is again 42. And yeah, so we now have train dataset and test dataset, and now we are gonna be using a data loader to convert them into train and test loaders. So data loader class with arguments as train dataset, batch size 32 and shuffle true would give us train loader, and for test loader with data loader class, test data set and batch size of 32. So device, we are defining our device here. It will check if GPU is available, otherwise it will just run the calculation on CPU. And this is the attentive FP model with all these default parameters. And this is the optimizer, Adam optimizer with model dot parameters. This is the learning rate and weight decay which we have been using. Now the main step is this train function. So this is the train function here, and let me go through each line of code here. So total loss here accumulates the loss over all batches. So we are initiating it with 0, and again the total samples would count the total number of samples processed. Correct predictions would count the total number of correct predictions, and model.train it sets the model to training mode, and which would enable certain layers, example dropout, to behave appropriately during training. Now we will iterate through the data in data loader or train loader here. So it will iterate through the batches of the training data, and data dot to device, it will move the batch of the data to the specified device, either GPU or CPU. Optimizer dot zero grad, it clears the gradient of all optimized tensors, and out is equal to model with all these graph features. So this would perform a forward pass through the model to get the raw output predictions. Now the predictions would be some float values, and we wanna convert it into zeros and ones. So this function here applies the sigmoid function to the raw model, which would convert them to the probabilities in the range of 0 or 1. Loss is equal to f dot binary cross entropy. So that's the loss function that we generally use for binary problems, and it computes the binary cross entropy between the predicted probabilities and true labels. So this is the predicted and these are the true labels. Loss dot backward performs the back propagation to compute the gradients. Optimizer dot step updates the model parameters using the computed gradients. And down here, line of code, it accumulates the total loss for the epochs, and data into number of graphs would represent the number of graphs in the batch, and that would be total loss here. And in the next line of code, this accumulates the total number of samples processed, and then here we calculate the number of correct predictions. So this converts the predicted probability to binary prediction. So if the predicted probability is greater than 0.5, it would be 1, otherwise it will be 0. And down here it would count the number of correct predictions in the batch, and it would accumulate it. Now so this line of code, it computes the accuracy for the epochs, which are correct predictions divided by total number of samples. And in the end, we wanna return the average loss and accuracy for the epoch. So this is the training function here. And similarly, we have the test function, which is pretty similar, except that we don't really have to deal with clearing the gradients and performing the back propagation. So except that all the code is same. So this is for the training, and we want to train for 75 epochs. And here this train function would return the train loss and train accuracy here. As you can see here, it would return the total loss or loss and accuracy. So we'll get loss and accuracy. Similarly, here test function would also give us the test loss and test accuracy, and we would append all these results into the empty list over here for each epoch. And in the end, we also wanna plot epoch versus train loss and test loss in one graph, and in another graph we wanna plot epochs versus train accuracy and test accuracy. So let's just run all these and train the model. So training has started. As you can see, for epoch 0, train loss is 0.7075 and test loss is 0.6856, and as we are going down, the train loss is decreasing and accuracy is increasing here as well. The test accuracy is 0.55 here, and as we are going down, the accuracy is increasing. So let's wait for it to finish and I will get back to you. So it has taken us 12 minutes and we have finished training, and these are the results here. So we started with loss of 0.7075 and it has come down to 0.4499, and similar is the case with test. And here we started with a loss of 0.6856 and accuracy of 0.55, and we have decreased the loss to 0.4946 and accuracy has increased to 0.77. So these are the plots, epochs versus loss. So as the number of epochs are increasing, we saw a decrease in the loss, and as the number of epochs increases, we saw a increase in the accuracy. And you can run it for more epochs and see if it kinds of plateaus out. So yeah, in the end we do wanna save this model, torch save model with the path. We can name it as model lipo class. So the model has been saved here, and we can use it for reproducibility. So yeah, that is how you can train a classification task with the help of graph neural networks and Pytorch geometric. So this is it for this video, and in the next video I will show you some more stuff. Thank you for watching.